Okay, so today we're going to do just the review for our first test. So if you're watching this and there's something that you get stuck on or you get confused, please make sure that you're coming to see one of your teachers. Okay, so up at the top, we're just writing the algebraic expressions. So it says the difference of a number and 13. Difference is subtraction. So when I do the difference of the two numbers, I'm going to just write it in order. The number minus 13. Number 2, the quotient. Quotient is division of 5 and a number. So when you have quotient, just like this one was in order, same thing here. 5 and a number. So what I tell my kids is that this fraction bar represents the word and. Right here. So 5 goes on top, the number goes on bottom. Number 3, 9 less than, and I'm going to take that out, 9 less than a number squared. Okay, so on this one you have to work backwards. A number squared means I'm going to do n and put a little square there. So you're multiplying it by itself. And then when you see 9 less than, make sure that you put this at the back. Minus 9. N squared minus 9. Okay, number 4. There's a lot here. 4 times the sum means addition, the sum of 5 and the quotient of y and 7. So I'm going to work backwards here. The quotient of y and 7. So I write that as y over 7, or y divided by 7. Okay, keep working backwards. It says the sum of 5 and this quotient. So sum means I'm adding, so I'm going to put the two together with addition. And then 4 times that whole thing. You have to put parentheses here or it will be incorrect. It's 4 times the whole sum. Okay, number 5. I rewrote this, I think, half of 2 more than a number. Okay, so when you talk about 2 more than a number, that's just another way of saying addition. So 2 more than a number looks like this. Okay, half of, you can do a couple different things here. You can divide the whole thing by 2, or you could do 1/2 times 2 plus n, or you can do 0.5 times 2 plus n. Any of those would be acceptable. Number 6, 6 times the quotient of a number in 4. So again, work backwards. The quotient of a number in 4, so that's division. Then it says 6 times that. So I do parentheses and I just put the 6 in front. 6 times the whole quotient. Okay, so the next part, we're now going backwards, so we're writing it in words. Write each algebraic expression in words. And I'm going to take that 2 off on this one because it's a little bit weird. So number 7, I first see that I'm doing a division sign. So I know up above when I do division, I said the quotient of. And now we're going to do 2 things. I'm going to do the top. So here, I have up here I had a number, on number 3, a number squared. This is a number cubed. So the quotient of a number cubed. And, so remember that word and represents the fraction bar, and 3. Okay, and then cover this up and check yourself. The quotient of, okay, so I know that's division, of a number cubed and 3, which is what is here. So I got that right. Okay, number 8. I'm going to work backwards here. So this, we start out by saying 10 less than. Okay, just like up above, we talked about that, where that number less than goes at the end. So 10 less than, and I'm going to say 5 times a number, or you could use the word product. So product is multiplication, the product of 5 and a number. Okay. Okay, number 9. So we've got a lot happening here. So the first thing I see is I am doing quotient, so I'm going to start out with that. The quotient of. Now, I'm doing the quotient of 2 things. So I am going to have that And I know the bottom is just a 2. So the top, though, I have the sum of two numbers, or I have 3 more than a number. There's a lot of ways you can write that. I'm going to say the quotient of 3 more than a number and 2. Okay, so this is the top, 3 more than a number, or you could say the sum of a number and 3. Lots of ways to do that. And number 10 is actually what we just had at the top. I'm going to use sum here. So I'm going to say the sum of a number and 3. Okay, next page. Complete the table. Okay, so on this, the first one, the set says real numbers less than 6. Okay, if you have trouble doing the words, draw yourself a number line, put 6 on. Okay, so it says less than 6. That means I have an open circle at 6 because it doesn't say equal to, and I'm going left or less than. Okay, now I can visually see what that's supposed to look like. So inequality notation, if you have a single number with an arrow, we always start with X. Okay, your inequality symbol, it should match the arrow, and that's the other reason I say draw the number line. Okay, this is the same direction as the arrow, and then I put the number. It does not get an equal sign because it's an open circle. It doesn't say equal to. Okay, interval notation. So on my number line, when you think of any number line, here's 0. After that would be -1, this would be +1. So my number line, this is going out to -infinity, and this is going out to +infinity. Okay, so if I'm doing interval notation, I'm going to always work from left to right. So I see that from the left, I have this arrow pointing this way. If I see the arrow pointing left, I'm going to start with -infinity. Infinities always get parentheses. Okay, so I'm starting here, -infinity. My interval comes up as I come to the right. It stops at 6, so I put comma 6. Open circles get parentheses. So that's interval notation. Okay, the second one, I know it's hard to see, but it's a closed circle and it's shaded in between, and then it's an open circle. So if you have 2 numbers on your number line, you are going to write the first number. You always start with the one on the left, -3. Okay, then I put my symbol, -3 is less than, X goes in the middle, I put another less than, and I put the far number 1. Okay, X is in the middle of the 2 numbers, and my symbols are open to the right, and this is how it always should be if you have 2 numbers. Now, because this is a closed circle right here, then I put an equal sign on this one, the -3. But the 1 remains with no equal sign because it's an open circle. Okay, so then interval notation. Remember, you work left to right. So from the left, I start at -3. I go to the right, and I stop at 1. So -3, comma 1. -3 has a closed circle, which means it gets a bracket. +1 has an open circle, which means it gets an infinity. I'm sorry, a parentheses. A parentheses. Okay, and the last one. Real numbers less than -5 or greater than or equal to 10. So there's a lot there. So I'm not even going to try anything until I draw a number line. -5 and 10. So this says real numbers less than -5. So it says less than, I'm going to put an open circle, and that's going to the left. Then it says or greater than or equal to 10. So because it has the equal to, I'm going to put a closed circle, and I shade to the right. So inequality notation. Up here, I had 1 piece, so I had something like this. This is the same thing, except I have 2 of them. So let's start with this one. Again, the arrow is pointing to the left. Okay, so I start with X, arrow is pointing to the left, and I put -5. So start with x, arrows pointing to the left, -5. No equal sign is an open circle. Or, and now I do this one. Okay, I still have a single number. So I start with x. But now the arrow is pointing to the right. So I put an arrow to the right, and then I put 10. It's a closed circle, so I put an equal sign underneath the inequality symbol. Okay, integral notation. So I have 2 pieces on my number line. I have 2 pieces for my inequality. I should have 2 intervals. Okay, so let's start with this one. Remember, this arrow here is heading out to -infinity. So that's where I start. -infinity, it's a parenthesis. As I move to the right, it stops at -5. Open circle gets a parenthesis. Then I use a U, that represents or, but in math notation. Okay, I come to the next one. Now this one starts at 10. So I'm going to start at 10. It has a closed circle, so it gets a bracket. And as I go to the right, my arrow is heading to +infinity. So comma, infinity, close parentheses. Okay, if you are having trouble with this, come and see one of your teachers before you take the test. Don't take the test and then say, I don't know how to do this. Come see a teacher. Okay, simplify the following expressions. So on this, yes, you will have a calculator, but you need to show all your work. Okay, so if you have to double check in the calculator, fine, but you should be showing all your work. Because we are going to look at that, and if your work doesn't match your answer, it's not going to get counted right. So you should be following PEMDAS. Okay, now this first one is kind of weird. There's no parentheses, there's no exponent, so I'm going to go to multiplication and division. So remember, when you do these two, you just work them from left to right. Okay, so as I move along here, I've got a 0 times a 6, I've got a -10 divided by a 2, and I've got a 2 times a 3. So that's what I'm going to do from left to right. So 0 times 6 is 0, plus 6, -10 divided by 2 is -5, 2 times 3 is +6. Okay, now I do addition and subtraction working from left to right. So 0 plus 6 is 6. 6 minus 5 is 1. And 1 plus 6 is 7. Okay, if you just put this whole thing in your calculator and you get 7 and you just put 7, if you are in Mrs. Stout's class, she will for sure mark it wrong. I am sure Coach Pacer will mark it wrong as well. You must show your work. Okay, number 18. So PEMDAS. Parentheses first. So I have this set on the inside here. So I'm going to do 2 bracket. I'm going to go ahead and do that 4 squared, which is 16, minus, and then in the parentheses, 8 minus 5 is 3. So now I'm going to take it out of the parentheses. Divided by, on the bottom here, I have 20 plus 3 times 2. So following order of operations, you should do multiplication first. So this is 20 plus 6. Okay, so now I have 2 times 16 minus 3 is 13 divided by 26. Okay, 2 times 13 is 26 divided by 26 is 1. So our final answer should be 1 there. Okay, number 19. So now I'm just combining like terms. So when I look through here, I have an m squared, I have an m squared, I've got a -3m and a 5m, and then I've got a p and a -6p. Okay, so I'm going to start with the m squares. M squared plus 3m squared is 4m squared. -3m plus 5m is positive 2m. And then I have a positive 1p minus 6p is -5p. I can't combine anything else, so that's my final answer. Okay, number 20. First thing I need to do is, this is a -1. I must distribute the -1 before I do anything else. So 3x minus 5x minus 6y plus 7x minus 4y. Now I'm going to combine like terms. So I've got a 3x, a negative 5x, and a 7x. 3 minus 5 is negative 2, plus 7 is positive 5, so 5x. And then I've got a negative 6y and a negative 4y, which is negative 10y. And that's my final answer. Okay, so the next 4 we're going to evaluate. Notice again, show your work for full credit. Okay, so I'm going to plug in the numbers. Negative 3 times negative 9 plus 9 times negative 9. So I'm just plugging in the numbers that they give me. So order of operations, I'm going to do no parentheses, no exponents, I'm going to do multiplication. Negative 3 times negative 9 is positive 27 plus, they can come in.
I'll be right back.
Okay, 9 times negative 9 is negative 81, and then I'm just going to add those together. So 27 plus negative 81 is negative 54. Okay, number 22. So plug in what they give us. 3 times x is negative 6, y is 8 minus 6 squared. Okay, so PEMDAS, I'm going to do parentheses first, and I'm going to go ahead and multiply those. So negative 18 times 8 minus 6 is 2 squared. Now there's one like this on the quiz that a lot of you missed because you squared both of these numbers. Okay, the exponent is only on the 2. So I leave the negative 18 alone. 2 squared is 4. And now I'm multiplying negative 18 with 4, and I get negative 72. Okay, 23. Negative 7 minus negative 4 plus 3. So parentheses first. Negative 4 plus 3 is negative 1. I have 2 negatives here, so 2 negatives make a positive. Negative 7 plus 1 is negative 6. And number 24, what's the value of A, B, C, and D? And it's all multiplied. So negative 3 times 2 times negative 5 times negative 3. Okay, so you just work from left to right. Negative 3 times 2 is negative 6. Negative 6 times negative 5 is positive 30. And positive 30 times negative 3 is negative 90. Okay, identify the domain and range of each relation and determine whether the relation is a function. So here, let's do this part first. This is just vertical line test. So if you draw a vertical line and it passes through one time anywhere on the graph, it is a function. So this one is a function, this one is a function, and this one is too. They're all functions. Okay, so now let's do domain and range. So domain for this one. Okay, so I work with boundary lines. So I say, okay, there's an arrow here and an arrow here. So if I try to draw a boundary line anywhere on this graph, I can't do that because it's going to keep on going forever and ever and ever. And it's going out towards negative infinity. Okay, same thing with the right. If I try to draw a boundary line on the right, it's going out to positive infinity. So this is all real numbers. Negative infinity to positive infinity. Okay, the range. So domain is your x's, range is your y's. The range, I go bottom to top. So if I try to draw a boundary line here, that starts at 0. And that gets a bracket because it's touching that 0. And as I go up, these arrows are going up also. So this is going to positive infinity. Okay, if you're having trouble with this, you need to come and see us for sure because this is stuff you have to know. Okay, number 26. I'm going to put arrows there. So domain. Again, if I have the 2 arrows here, I have the 2 arrows here. My domain is the same. Negative infinity to positive infinity. And you will see that a lot. Okay, the range. So range, you go bottom to top by y values. If I try to draw a boundary line down here, I can't because the arrows keep going. So this starts at negative infinity. And as I come up, I can draw a boundary line right here at the top, which is at 0. And that gets a bracket. Okay, and then 27, again, arrows. So domain, this is going to negative infinity, this is going to positive infinity. So my domain, again, is all real numbers, or negative infinity to positive infinity. My range, if I try to draw a boundary line at the bottom, I can't because this keeps going. So negative infinity, and if I try to draw a boundary line at the top, this keeps going to positive infinity. So they're both all real numbers. Okay, the next one is identify the parent function. So we've talked about these parent functions. This parent function is the absolute value. Y equals absolute value of x. Make sure that you know both of those. Okay, it says describe two characteristics of the graph. So I'm going to say one thing is the vertex. The vertex is at 0, 0. And I'm going to say, secondly, it's symmetric. So this side looks exactly like this side. It's like a mirror image of itself. Then it says give domain and range. So the domain, again, double arrows is negative infinity to positive infinity. And range, we just did this one up above right here. So if I draw a boundary line right here, it starts at 0 and goes to infinity. Okay, number 29. This is the square root function, y equals square root of x. Again, make sure you know both of those. So one characteristics, again, vertex is at 0, 0. A second one, I could say it's only positive values, so it's only over here. It doesn't have like a bottom part here. So only positive values. You could say it's increasing the whole time, anything like that. Domain. So I go left to right. Now here I don't have an arrow. So the farthest left value I can draw is at 0. So bracket 0, and I have an arrow going to the right. So infinity. Range, same thing. Start here at the bottom. I start at 0, 0, 2, and it's going up. Even though there's a little bit it's going up, this is still going up, 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 up. So to infinity. Okay, number 30, that's the quadratic. So y equals x squared. I'm going to say the same two things about absolute value. I'm going to say vertex at 0, 0, and I'm going to say it's symmetric. It's still a mirror image of itself. Domain, negative infinity to positive infinity, because it has double arrows. Range starts at 0, so bracket 0 to infinity. And number 31, this is the cubic. So y equals x cubed. Let's see, passes through the origin. So passes through 0, 0. And I'm going to say it's symmetric across 0, 0, or across the origin. If I was to rotate it, it would be the same thing. We'll talk about that later on in the year. Okay, domain. I have an arrow here and an arrow here. So domain is all real numbers. Range. Bottom to top, I have 2 arrows, so it's also all real numbers. Okay, and the last page, solving inequalities. 31, let's distribute. So negative 4x plus 8 is greater than 12. Subtract 8. Negative 4x is greater than 4. Divide by negative 4. I'm dividing by a negative. When I divide by a negative, I have to flip the sign. So this is x is less than negative 1. Negative 1, open circle. It's pointing to the left, so I shade to the left. 32, distribute. 90 is less than 30x minus 15. I like the x on the left, so I'm not even going to start this problem like that. I'm going to rewrite it. I'm going to put 30x minus 5, flip the sign, and put 90. Now I have my x on the right. Add 5. 30x is greater than 95. Divide by 30. So x is greater than, let's see, put that as a decimal, 3.1, let's say 3.2. So 3.2, open circle is pointing to the right, so I arrow to the right. 32, I'm just going to solve them separately. So add 5, 2x is less than 8, divide by 2, x is less than 4, or divide by 3, x is greater than 6. So I'm going to graph both of those. So 4, 5, 6. Open circle at 4, it's pointing to the left. This one's an open circle at 6, pointing to the right. If it says or, they should be outward like this, okay, facing apart. 33. I'm going to switch this one because I don't like the x on the right. X is greater than negative 8. Okay, then I'm going to solve this one. Minus 5. Negative 4x is greater than or equal to 20. Divide by negative 4. I'm dividing by a negative. Flip the sign. X is less than or equal to negative 5. So I have x greater than negative 8 and x is less than or equal to negative 5. So negative 8, open circle, shade to the right. Negative 7, negative 6, negative 5. Closed circle, shade to the left. So if you see and, they should be pointing into each other. Okay? If you have something where they're both pointing to the right, that something's wrong. Or both pointing to the left, something's wrong. They should either point to the same way or the opposite way. Okay, 34. So I'm going to separate this. I'm going to do negative 2 less than or equal to x plus 3. And then I'm going to do this one, x plus 3 less than 9. Okay, I'm going to solve this. So subtract 3. Negative 5 is less than or equal to x. I don't like the x right here. I'm going to flip it. On this one, I'm going to subtract 3. X is less than 6. So I'm going to graph those. So I have negative 5 over here. Closed circle, shade to the right. And I have positive 6, open circle, shade to the left. They're both pointing in. I'm good to go. And the last one. So same thing, separate it out. 3x plus 2 is less than x plus 4. And then the other one, x plus 4 is less than or equal to 3x plus 10. Okay, so I'm going to solve the first one. I like my x's on the left. So subtract x. 2x plus 2 is less than 4. Subtract 2. 2x is less than 2. Divide by 2. X is less than 1. Again, I like my x's on the left. Minus 3x. Negative 2x plus 4 is less than or equal to 10. Minus 4. Negative 2x is less than or equal to 6. Okay, I just divided by a negative. I have to flip the sign. So negative 3. Okay, so I have negative 3 over here is a closed circle pointing to the right. And I have positive 1 is an open circle pointing to the left. Okay, if you have questions on the review, you have to come and see one of us before the test. Okay, hopefully watching this helped you out some. Otherwise, that's it.